Hi, Professor.
Hello. Okay, I'm going to talk about the second exam. Question. Did I, first of all, did I first remember, let's recall the Gram-Schmidt process. You don't need to know the proof because that's a little complicated. We have to talk about projection and all that. You must know the method. Step 1, V1 equal to U1. Step 2, V2 is equal to
U2
good. Tell me.
minus
U2 minus U2 V1
U1
over normal
modulus
V1 squared.
V1.
V1. Very
V1.
good. Step 3, V3 equal to U3 minus norm of U3 V2, sorry, inner product over norm of V2 squared, V2 minus inner product U3 V1 over norm of V1 squared, V1, right? And like this and so on. Okay, so that's the story. Did I give any homework problems? Yeah?
No, I don't think so.
No?
No.
No, really? Really? I didn't give any homework problems. Let me catch these guys. Let me catch these guys. Wait. Really, I didn't give any homework problems? Somebody said I don't think so. Even Arlie is saying that.
You did it, Professor.
I did not. Okay. Oh, I did not. That's true. Oh, that's true. How come I did not? Okay, now let's talk about the exam then. Okay, good. So let's talk about the exam. Okay, exam will be like this. Exam 2, Tuesday, December 8. We start at 1:45. You can take time up to 3:15 p.m. Okay, one problem. One problem on Gram-Schmidt orthonormal process. So you find orthogonal basis and then orthonormalize. Okay, this one will be, just a minute. So let us. I showed you two problems. I showed you two problems. So let's take an example like this. Another problem. I'm in R3. Three have the inner product UV inner product UV is given as U1 V1 plus 2 U2 V2 plus 3 U3 V3. Use Gram-Schmidt to transform into an orthonormal basis. Okay, so let's start. So remember, R3 means what? A vector is given like this: U1, U2, U3. Yes, and V is V1, V2, V3. So V1 is E1. So that is 1, 1, 1. V2 is U2 minus, you will tell me because you're going to take the exam.
U1.
Good, come on. Tell me, come on, finish it.
The inner product. The inner product.
U2 minus inner product U2 V1
One.
over norm of V1
V1.
squared, then
V1.
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 Okay, now wait. So inner product U2 V1 will be what? Will be the inner product of, so U2 is 1, 1, 0. So inner product of 1, 1, 0, comma, V1. V1 is 1, 1, 1. Be very careful. See how it goes. U1 V1 plus 2 U2 V2 plus 3 U3 V3. So U1 V1 1 plus 2 U2 V2 2 plus 3, but that is 0, so that is 3. And how will I find norm of V1 squared? Is inner product V1 V1. So that is V1 is 1, 1, 1. So this is 1, 1, 1. With 1, 1, 1 inner product. So that is 1 plus 2 plus 3, 6. Right? So V2 will be U2 1 1 0 minus U2 V1, that is 3 over 6 V1. V1 is U1, isn't it? So that is 1 1 0 minus half 1 minus half, half, 1 minus half, half, 0 minus half, 0 minus half, minus half. So that is V2. So I got V1 is 111, V2, V1, and V2 is half, half, minus half. Now comes V3. So this is U3 minus inner product U3 V2 over norm of V2 squared minus inner product U3 V1 over norm of V1 squared, V2 V1. Yes, correct. So I have to find these values now. It's very difficult to do these things on iPad. Disgusting. So U3 V2. What the hell is U3? U3 is what?
$100.
U3 is 100. Thank you. 100. V2 is half, half minus half. So that is E1 V1 plus 2 U2 V2 like this, right? 1 is half plus 2 U2 V2, that's out, plus 2 3 U3 V3, that's out. So just half. Okay. What is norm of V2 squared? Inner product V2 comma V2. Now V2 is this guy. So we can do it straight, right? Half times half, 1/4, plus twice half times half, 1/4, plus 3 times minus half times minus half, 1/4. So 1 plus 2 plus 3. 3 plus 3 is 6 by 4. Okay, then U3 V1. U3 100 V1. V1 is the same as U1. 111. So that is simply 1. That's it. And V1 squared. Did I find V1 squared? V1 is 111. norm of V1 squared. So 1, 1, 1. So 1 times 1 plus 2 times 1 plus 3 times 1, 6. So V3 is U3, which is 100 minus U3V2 is half over norm of V2 squared is 3 by 2 V2, no? V2, half minus half. Half minus half. And then minus U3V1 is 1 upon V1 squared is 6. And times V1. V1 is U1. So let's see what we get. So what do we get? 1 minus 2 by 6. 1 minus 1/3.
You're still eating. Mine.
Who is that? Stop making the noise.
You really like these, don't you?
Samuel Wong, can you stop making this noise?
Potato chips.
0 minus 1/6 minus 1/6 minus 2 by 6. Plus 1/6 minus 1/6, 0. Okay, so that's your V3. But that's not the answer finally, because I have to find orthonormal basis. So Q1 is V1 upon norm of V1 squared. Q1. Q2 is V2 upon norm of V2 squared. Q3 is V3 upon norm of V3 squared. So that is norm of V1 squared is what? 6. And V1 is 111. Acha. 111 over 6. So that is 1/6, 1/6, 1/6. No. No. Not V1 squared. V1. Nobody stopped me. Hey. Square root of 6. Okay, and what is V2? V2. Half minus half. Over norm of V2. Norm of V2? Now where is norm of V2? Norm of V2 squared is 3 by 2. So norm of V2 is root 3 upon square root of 3 by 2. So that is half upon root 2. Okay. 1 upon root 6 1 upon root 6 minus 1 upon root 6. Root 3 means there 2, the square root of 2 goes up, right? Q3 now V3, I have to find V3 squared, no? Norm of V3 squared. So there is V3 still, I can see 2 upon 3 times 2 upon 3, 4 upon 9, plus 2 times minus 1/3 times minus 1/3, 9, plus 3 times 0 times 0. So that is 6 upon 9, 2 by 3. So this will be V6 is 2/3 minus 1/3 0 upon square root of 2 by 3. So Q3 is square root of 2 by 3 minus 1/3 square root of 3 by square root of 2. So minus 1 over root 6, 0. Okay, that's the answer. So I did 3 problems like this. So you should be all set for. So that's one question. So that's one question on Gram-Schmidt. One problem diagonalization. I will give you just a minute. Do you want a 3 by 3 matrix or 2 by 2 matrix for diagonalization?
2 by 2, please.
2 by 2, please.
Excuse me, 3 by 3.
No.
No, you just gave us option, please.
No, who gave you options?
You just asked 2 by 2 or 3 by
I
3.
was just checking whether the people will. No. That is not a good idea. Okay, let's see. Diagonalization. No. Just a minute, wait. Yeah. So eigenvalues, eigenvectors, how to diagonalize a matrix. Yeah. Right. So here is the question. How do you, yes. So this is a problem like this. So this is a kind of a problem. Find a matrix P that diagonalizes and then evaluate you have to check that it is the diagonalized. So P inverse AP. And that will turn out to be a diagonal matrix, right? So how do you do this? So step one, find the characteristic equation naturally. How do you find the
Professor, sorry. Before we doing that, can you please go back to the question that we just did on the top? Yeah, for V2, V1, we found it's 3, but I'm thinking it's 2.
What is V2, V1? V3, V1?
Yeah, at the beginning. At the beginning.
Where V3, V1?
There is a condition in the problem. Can you go to the problem itself, Professor? Maybe they will see why. Yes, there's a condition here saying UV, UV equal to U1 V1 plus 2 U2 V2. That's why the result is not 2, it's 3.
Oh, okay. Thank you so much.
Thank you.
You're welcome.
Okay, step one, characteristic equation. So determinant of lambda I so what do you have? 0 minus lambda. 0 minus 2, 1, 2 minus lambda, 1, 1, 0, 3 minus lambda. So minus lambda minus 0, okay, minus 2 so lambda minus 2 minus of this, that between lambda minus 2, lambda minus 2 common factor, so I have two roots, lambda equal to 1 and 2. Lambda equal to 2 is a repeated root, right? Okay, these are the eigenvalues. Eigenvalues. Two is a repeated root, remember. Now I have to find eigenvectors. So AX is lambda x. So A is 0, 0, minus 2, 1, 2, 1, 1, 0, 3, x1, x2, x3, lambda x, lambda x1, lambda x2, lambda x3. Okay, now when lambda equal to 1, for lambda equal to 1, we have what? Minus 2x3, x1 plus 2x2 plus x3, x1 plus 3x3, lambda 1, x1, x2, x3. So minus 2x3 is x1. x1 plus 2x2 plus x3 is x2. x1 plus 3x3 is x3. So if I put x1 equal to minus 2x3 here, so I get minus 2x3 plus 2x2 plus x3 is x2. So minus x3 is equal to minus x2. So x2 equal to x3. Very good. So x1, x2, x3 becomes what? x1 is minus 2x3, x2 is x3, x3. So x3, that's a scalar. x3 any scalar. Okay, that's the basis of one of the eigenspaces. Now for lambda equal to, I think 2, isn't it? 2. What do you have? Well, let's see. Let me get it correct. Minus 2x3 x1 plus 2x2 plus x3 x1 plus 3x3 so then this is lambda equal to 2. So minus 2x3 is equal to 2x1. So this cancels out. So x1 is equal to minus x3. And x2 is anything. x2 is free. So I write it this way. x1 is minus x3, na? x3 is minus x1. So x1, x2, x3 is minus x1. So since this is a repeated root, this is what you will be getting. x1, 1, 0, minus 1, plus x2, 0, 1, 0. x1, x2 in scalars. So what are the vectors? So P inverse AP. So the diagonal matrix, the that P that diagonalizes A is P. Let's take it straight. This is minus 2, 1, 1. Don't change the order. This is 1, 0, minus 1, 0, 1, 0. That is step 2. So step 3. Here you have to find P inverse AP. To find P inverse AP. Let us quickly find AP. A is so this times that 0 times minus 2 to 0. Minus 2 plus 2 plus 1. Minus 2 plus 2 plus 1. Minus 2 plus 3. Minus 2 plus 3. This one, 0 times that, 0 times this, minus 2, 2. 1 minus 1. 1 minus 3. Okay, now find P inverse. Okay, determinant of P good news. So P is the matrix minus 2, 1, 0. One zero one. One minus 1 0. Okay. So the way we do it, plus minus plus minus plus minus plus minus plus, matrix of cofactors. Minus 1. Then hey, no. 2 minus 1 with a negative sign. 1. Minus 2. with a negative sign. -1. Now, adjoint is just its transpose, no? So A inverse, yeah, P inverse. This is determinant of P is -1, so that's very easy. Now, what was P times, what was, so this is P inverse. What is AP? Where did I find AP? This is A, not A, this is AP. Come on. This is AP.
AP is -220.
Wait, AP is -220 102
1 -20.
Thank you. So P inverse AP is two plus 0 Did I make some mistake? What is P? No, okay. Let's see. 2 plus 0 minus 1. Okay. Minus 2 plus 0 minus 2, that's 0. Minus 2 plus 1 plus 1, that is 0. Good, everything so far is good. This times that is 2. Some mistakes. No. Minus 2 plus 2, 0. Minus 2 plus 4. Minus 2 plus 4. 2 minus 2, 0. 0, 0, 0. 0, 0, 0. 0, 2. Wonderful. Which is diagonal. Okay, so these are two questions. Next.
Professor,
Yes.
could you verify again PN versus AP?
Yeah, what? I just did it. And it is a diagonal matrix.
Okay.
Nothing to worry about that. Once it is a diagonal matrix, it's fine.
Okay.
As long as it is a diagonal matrix, yeah. Okay, then some theorems I said. Okay, now let us see. What was the theorems that I say? This is important. Can somebody remind me? Okay, no. Then I will ask you to prove one theorem. Yeah. Maybe I will put them in the final, but now let us focus on inner products. Just a minute.
It's only 3 questions, right?
Okay. Two theorems. What are the two theorems? If W of and everything is real. So if an inner product space V, prove that, done in class, you will see. Only the zero vector is common between them. That's one theorem.
Will you just state the term or proof?
Proof? What do you mean? Ah. if is an orthogonal set of, this is very important, non-zero vectors in an inner product space, S is linearly independent. Okay, two computational problems, two theorems, and then that's it. There will be 5 questions. There will be exactly 5 questions, not more than that. So 1, 2, good. One problem. What kind of a problem? So, sorry?
No, I would say fun problem or
Now, you see, we did problems like this. We did some problems, say, okay, problems from inner product, that's it. So I will tell you. From on inner products. What kind of a problem? So let me tell you. Just a minute, wait. Let it open. So this is November 24. Number 1, 2, 3, and there I have written, I put a star, important I said. And then I said problems, let me share with you. That's it. Just these problems, you see. Any one of them. This one and this one are particularly important. That is your exam. And I have nothing more to say. That's your exam. Any questions, anybody?
And those questions are all for November 24th?
Sorry?
Those questions are all for
All on November 24, exactly.
Okay, thank you.
If you go to the notes of November 24, you will see this. And I'm asking you that give most importance to this one and this one.
Is there any way you can specify for the theorem also?
I've just specified 1 and 2.
For the theorem also? Okay.
Yes.
Okay, got it. Okay, thank you,
Exactly these
Professor.
two theorems. Exactly.
Okay, thank you, Professor.
Yes. Exactly these two theorems. Okay?
Just from these theorems, we're gonna have one.
No, 2. 2 computations, 2 theorems, and 1 problem. 5 questions.
5 questions.
Yes.
I think I'm gonna have like I can answer 2 of them because it takes
Okay, I will
long
make it.
time.
Okay. I will make it 7 questions.
No, sorry. I withdraw.
We okay with 5. Thank you.
5 questions. Okay. Why? Because I'm giving you a lot of time. Exam 2. So let's see. Tuesday. I said 1:45. I will be ready at 1:40 to 3:15. Oh yeah, a lot of time. Oh my goodness. Yeah, a lot of time.
Professor,
Yeah.
can we make it to 3:25?
No.
Please.
Absolutely not.
Thank you. You're the best.
Okay, and now then I will say finally, so this is the Tuesday. The Thursday we meet the last class, and Thursday that's the last topic we meet. The usual class 1:40 p.m. And Friday is the review. Review. Okay. Okay, that's it. You are done for today. You recall that I told you that I will be asking some theorems on eigenvectors, eigenvalues. Not now. They will be for the final. For the second exam, only these 5. Focus only on these 5. That's it.
So, Professor, the final is going to be cumulative or no?
Not exactly. I will let you know. I will let you know that. I will let you know. I will
Okay,
let
thank
know.
you.
It will not be exactly. No, it won't be cumulative. I will give you a list of topics actually.
Thank you so much.
Yes, you can talk to me after class, sure. Okay, that's basically all I need to say today, and I can end the meeting, unless if you have any questions. Thank you. Please come on time so that we can start at sharp 1:45. Okay. Yeah. Thank you very much. All of you have a good day, and please don't miss the class. Don't miss the exam. Don't miss the exam. Yeah. What is your question? Okay, private. Okay. Okay, all of you can leave now except Arlie Evans. He wants to talk to me. Let me end the meeting. You join me, okay? Harley?
Okay, Professor.